In this video, I'll explain basics of probability. First, let us see what is random experiment. An experiment in which all possible outcomes are known in advance, but we cannot predict as to which of them will occur when we perform the experiment is called as random experiment. Say, for example, tossing a coin once. Before you are tossing a coin, you know what are the possible outcomes you will get. That is either head or tail. But we cannot predict what outcome you are going to get when you toss a coin. We will be knowing the possible outcomes, but we cannot predict what outcome you are going to get when you toss a coin. So, such experiment is random experiment. Tossing a coin is an example of random experiment. Rolling a die. So when you roll a die, you have six possible outcomes: 1, 2, 3, 4, 5, 6. These are the numbers which appear on the die. So before rolling a die, you know what are the possible outcomes, but you can't predict what you are going to get when you roll a die. Drawing a card from pack of 52 playing cards. You cannot predict as which card you are going to get before drawing the card. So these kind of experiment are called as random experiments. Trial means performing an experiment is called as a trial. So for example, tossing a coin is a trial. Rolling a die is a trial. Similarly, here, tossing a coin twice is also a random experiment. Tossing a coin thrice is also a random experiment where you will be knowing what are the possible outcomes, but you can't predict which outcome you are going to get when you toss a coin. Now, let us see about sample space. Sample space means it is set of all possible outcomes of a random experiment. That sample space is denoted by capital letter S. We write all possible outcomes in a set form. So that is how we use the concept of set into probability. Set of all possible outcomes of a random experiment. When you list out all outcomes of a random experiment, then that becomes sample space and it is denoted by S. Size of the sample space is nothing but total number of outcomes, all possible outcomes, and hence number of elements in the sample space is denoted by N of S. For example, when you toss a coin twice, you will have these possible outcomes. Tossing a coin twice means you have to write the sample space, means all possible outcomes. When you toss a coin once, you will get either head or tail. So this is the first toss. So when you toss a coin second time, then again you will have two possible outcomes like this. We call it as a tree diagram of writing all possible outcomes. So in the first toss, head or tail. Suppose if I get head, then once again you have to toss a coin, then you will get either head or tail. Here also, suppose if you get tail, then you have to toss a coin. So H or tail. So H, head in both tosses, head tail head or tail tail. So this is the sample space of the given random experiment. It has four elements. So number of elements in the sample space equal to 4. Next is about sample point. Sample point means each outcome of an experiment is called as sample point. So, for example, in rolling a die, total outcomes are 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are all sample points. In tossing a coin once, head and tail are the possible outcomes. So head is one sample point, tail is another sample point. So member of that sample space is called as sample point. Now next concept is event. What is an event? It is set of one or more possible outcomes of an experiment, or in other words, we can say it is a subset of the sample space. See, for example, if you roll a die or throw a die, getting a number less than 5, this is an event, because when you list numbers less than 5 which appear when you roll a die, the possibilities are 1, 2, 3, 4. This is a subset of 1, 2, 3, 4, 5, 6. Subset means every element of this set should be in the sample space. This is the sample space of that experiment. When you roll a die, you have 6 possibilities. So this is a part of it, that is getting a number less than 5. Getting a number less than 5 means possibilities are 1, 2, 3, 4. So this is an event. So any subset of the sample space form an event of the given random experiment. Now you have to see what are types of events. So the first type is impossible event. Impossible event corresponds to the empty set or null set, because empty set is a subset of every set. For example, in rolling a die, getting a number greater than 6. This is an impossible event because all possible outcomes are 1, 2, 3, 4, 5, 6. When you roll a die, you can never get a number greater than 6. Hence, the event corresponds to a null set. It's an impossible event. What is sure event? Sure event means it corresponds to the whole sample space. That means E equal to yes, because every set is a subset of itself, due to which you have these events: impossible event and sure event. For example, getting a number less than 7. This is an event. So when you write this event, you will have a number on a die less than 7 as 1, 2, 3, 4, 5, 6. Hence, this corresponds to the whole sample space of the random experiment. So this is a sure event. Simple event means it contains only one sample pointer. See, for example, getting an even prime number. We know that there is only one even prime number, which is 2. Therefore, E equal to 2. Here, this corresponds to, all these examples corresponds to random experiment of throwing a die. So, getting an even prime number E equal to set containing 2. Hence, this is a simple event. Next, compound event. So, it is a compound event. Compound event means it has more than one sample point. Number of elements in that event is more than one. So, example, getting odd number E equal to 135. When you throw a die, there are total 6 possible outcomes, out of which odd numbers are 135. Therefore, this event is compound event. Next type of events are exhaustive events. A set of events are said to be exhaustive when these events taken together form the whole sample space. That means when you combine all those events, given events, then if you get the entire sample space, we call those events as exhaustive events. For example, when you roll a die, if even is one of the event is getting an odd number, another event is getting an even number. So, getting an odd number even, favorable outcomes are 1, 3, 5. E2 favorable outcomes are 2, 4, 6. So, when you combine these two events, then you will get the entire sample space. Then such events are called as exhaustive events. Mutually exclusive events. Events that cannot occur at the same time are called as mutually exclusive events. Say, for example, these two events itself, when you take, they are mutually exclusive because when you give the event as getting an odd number, at that time this event can never occur, because when you get an odd number, it is just an odd number, it can't be even number. Therefore, even intersection E2, mathematically mutually exclusive means if their intersection is a null set, so they do not have any element in common, hence we call the events as mutually exclusive. Now these two events are mutually exclusive as well as exhaustive, because union is the entire sample space and intersection is the null set. Next, complementary events. When there are two events such that one event can occur if and only if the other does not take place, then such events are known as complementary events. The name itself says. Even is getting an odd number. When you have this event happening, then getting an even number, this event can never happen. So, therefore, these two events are complementary events. So, if E is an event, then its complementary event is denoted as E dash usually. Therefore, E2 and E1 are complementary events. So, E2 equal to E1 dash. This is the one representation for complementary events. Equally likely events. Outcomes are equally possible. Such events are called as equally likely events. See, for example, in tossing a coin, getting head or getting tail. Suppose one event is getting head, another event is getting tail. Then these two events are equally likely because the chance of getting head is equal to the chance of getting tail. So like there are two outcomes. What is the possibility of getting head? 1 by 2. What is the possibility of getting tail? That is also 1 by 2. Hence these events are called as equally likely events. And importantly, this should happen in a fair or unbiased coin. So, unbiased coin means your regular coin. Biased coin means the coin is deformed so that get the chance of getting head or the chance of getting tail is more. It is not equally likely. So, for example, when you have a coin, if you bend it on sides, on any of the face, on sides, so that when you toss a coin it stand on those bent sides, hence the probability of getting head or getting tail will be more than the other. So such coin is called as biased coin. We have to deform the coin to change its probability. Such coin is called as biased coin. Here, whenever it is not mentioned, it is unbiased coin or regular coin or fair coin, where the probability of getting head equal to the probability of getting tail. That was all the theoretical definitions of the terminologies. Now, whenever a random experiment is given, let us see how to write its sample space. So, for example, if you have random experiment of tossing a coin once, so then you will get either head or tail. So, S is equal to H comma T. So, rolling a die. So in this case, the sample space, all possible outcomes are 1, 2, 3, 4, 5, 6. Suppose these are very simple random experiments. Now, suppose if you toss a coin and if you get a head, you have to roll a die. Otherwise, you need not roll a die. So first is tossing a coin. If you toss a coin, you will get either head or tail. Next, if you get head, then you have to roll a die. So when you roll a die, you have 1, 2, 3, 4, 5, 6. These are the possible outcomes. Therefore, the sample space must be written as H comma 1, H comma 2, H comma 3, H comma 4, H comma 5, H comma 6, then just T, because when you get tail, need not roll a die. It is just tossing a coin. So suppose if you first roll a die, then if you get even number, then you have to toss a coin. If you get odd number, then you have to roll a die again. So in this case, first rolling a die. So possible outcomes are 1, 2, 3, 4, 5, 6 when you roll a die. Next, if you get even number, you have to toss a coin. So even number, these are the possibilities. Toss a coin. When you toss a coin, you will get HT, head or tail, head or tail. So if you get an odd number, you have to roll a die. So that is 1, 2, 3, 4, 5, 6 here. For 3, 1, 2, 3, 4, 5, 6, and for 5, 1, 2, 3, 4, 5, 6. Therefore, the sample space becomes, so here it is 1, comma 1, 1, comma 2, 1, comma 3, so on up to 1, comma 6. But with the 2, 2, comma H, 2, comma T. Then with the 3, 3, comma 1, 2, 3, comma 6, 4, comma H and 4, comma T. Then 5, comma 1 to 5, comma 6. Then 6, comma H and 6, comma T. So this is how we write the sample space for any given random experiment. When you roll a die two times, see, if the random experiment is rolling a die twice, so first time when you roll a die, you have six possible outcomes, 1, 2, 3, 4, 5, 6. So one, if you get any possible outcome, any outcome, then you have to roll a die again. So 1 to 6, 1 to 6. For each outcome, other possibilities you have to write. Hence, sample space becomes 1, comma 1, 1, comma 2, so on up to 1, comma 6. Similarly with the 2, 2, comma 1 to 2, comma 6. Then 3, comma 1, like that. So n of s is equal to 36. Initially, when you roll a die once, 6 elements. Here there are 6 into 6, 36 elements when you roll a die twice. Similarly, when you toss a coin once, HT. When you toss a coin twice, first time toss head or tail, second time HT. Suppose if you toss a coin thrice, then HT, H or T, H or T, then H or T. So all together you will have S is equal to H, H, H. Meaning of this is all three heads, three times tossing a coin. So all three heads, then H, H, T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. So there are totally n of S is equal to 8 possible outcomes when you toss a coin thrice. This is how we find out the sample space of the random experiment. Now, once you find the sample space of the random experiment, then to check whether the events are mutually exclusive or exhaustive. So, in that case, you have to find out possible outcomes for the given events, E1, E2. Possible outcomes are nothing but the outcomes favorable to that event. So, any outcome, if it satisfies the condition of the given event, then that will be there in the set E1. E2 means another event. So I'm just taking an example, even and E2, two events. Now, if you want to check whether they are mutually exclusive, then you have to find out even intersection E2. We are using the concept of sets, the operations on sets, to understand or to find out all these in probability. So even intersection E2, if you get empty set, then the events are mutually exclusive. If you get even union E2 is equal to the entire sample space, then the events are exhaustive. So this is how we find out whether the events are mutually exclusive or exhaustive. Now, to find out the complement, suppose E is the given event. To find out E dash, then it is S minus E. From the sample space, you have to subtract the given event E to get its complement. See, for example, suppose S is equal to tossing a coin twice, HTT, HTT. These are the possible outcomes. So E1 is getting exactly one head, exactly one head. This is E1. Another event E2 is getting tail. So getting tail. So in this case, TT, TH, then HT. Getting a tail. So it can be more than one tail here, but one tail must be there. So now when you find out even intersection E2, it is not a null set. Even intersection E2 equal to HT, So this is not equal to null set. Hence these events are not mutually exclusive. Are they exhaustive? Even union E2 you check. When you combine these two events, you will get HT, then it is not equal to the entire sample space. Hence, these two events are not exhaustive. Hence, these two events are neither mutually exclusive nor exhaustive. This is how we check whether the given events are exclusive or and exhaustive. So how to find out complement of even? So even dash is equal to S minus E. So S is this set. So S minus E means the elements which are not in even. So which are TT and HH. So this is complement of even. This is how we find out the complement. Therefore, for exclusiveness, you find the intersection, and for exhaustiveness, you have to find out the union of the given events. So, if more than two events are given, say, suppose three events, even E2, E3. So, to say mutually exclusive, even intersection E2 should be empty, E2 intersection E3 should be empty, and even intersection E3 should be empty. Then, even intersection E2 intersection E3 must be empty. Then only we can say that these events are mutually exclusive. Now let us define the concept of probability. Probability of any event is nothing but it is the chance of occurrence of that event, because random experiment is that kind of experiment where we cannot predict the outcome in advance, though we know the possible outcomes. That's why we are just finding the chance of occurrence of that particular events. So there is this theory of probability, that is classical or mathematical probability. So this probability is applicable when the cases are equally likely and total number of cases is finite. So total possible outcomes is finite, and each outcome is equally likely, then in that case we apply the concept of classical probability. So using the classical probability, the probability of any event A, I have named the event as A, is given by the number of favorable cases to the event A divided by total number of cases. Total number of cases. So this is how we calculate the probability of an event. So number of favorable cases to that event A divided by total number of cases. Say for example, you have the random experiment of rolling a die. So S is equal to 1, 2, 3, 4, 5, 6. Here there are finite cases. Total outcomes are finite and each outcome is equally likely because chance of occurrence of each outcome is equal 1 by 6, which is therefore now if I give you an event A as getting odd number. So in that case, favorable cases are 1, 3, 5. Hence, probability of this event is P of A equal to 3 by total 6. Total there are 6 elements in the sample space. Here there are 3 elements favorable to this case. So 3 by 6, that is nothing but 1 by 2. 1 by 2 meaning is the chance of occurrence of this event is 50%. There is a 50% chance of occurrence of this event, 1 by 2. So probability in mathematical probability theory, P of A value always lies between 0 and 1, may be equal to 0 and it may be equal to 1. Exactly equal to 1 means it is sure event. Equal to 0 means it is an impossible event. Suppose if I give you A equal to getting a number greater than 6, in that case, what are the favorable outcomes? There is no number on a die which is more than 6. Therefore, you will get A as null set. Hence, P of A, what is the chance of occurrence of this event? You know that this event will never occur. So, number of elements in A is 0 divided by total 6, so it gives you 0. So in the case of impossible event, its probability is always 0. In the case of sure event, see for example, A is getting an even number or odd number. So what are the outcomes favorable to this event, even or odd? All possible outcomes will come within this event. So therefore, P of A equal to 6 by 6, which is equal to 1. Therefore, in this case, it is equal to 1 means it's a sure event. If this event is given, then you can directly say that this event will definitely occur. The chance of occurrence is 100%. 1 means it is 100%. 0 means that will never occur. In between any value means 50%. 1 by 4 means 25% chance of occurrence. 3 by 4 means 75% chance of occurrence. So that is how we define probability in classical theory of probability. Now, if you want to find out P of A dash, the probability of A dash, then it is equal to 1 minus P of A, because the total probability of events must be equal to 1. P of A plus P of A dash must be equal to 1. Hence, P of A dash is equal to 1 minus P of A. You have to remember one more thing. The classical definition of probability fails if the cases are not equally likely and there are infinite number of outcomes for the given random experiment. So in that case, you can't apply P of A as this formula, number of favorable cases to the event A by total number of cases. That won't apply if these conditions are violated. Now, let me illustrate the concept of probability with a few problems. See the first one, three unbiased coins are tossed simultaneously. Find the probability of getting. These are the sub questions. First, three coins are tossed. Let us write the sample spaces. So, H, 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 T, H, T, H, H, T, T. Then with the T, 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 H, T, H, T, T, H, H, T, T, T. So total there are 8 possible outcomes for the given random experiment. See the first one, at least 2 hits. What is the probability of getting at least 2 hits? So P of A, I'll name for the first one. If this is event is getting at least 2 hits, number of outcomes favorable to this event. which outcomes out of these eight will favor this event? At least two heads, minimum two heads, maybe more than two. So that is h h t h t h. These are minimum two heads. Then h h h, maybe more than two heads. So these outcomes, as well as, see here, with the t, this is with the h, then t h h, this outcome will favor, this is not, this is not, this will not, this hth, hht, I have written hhh, thh. Therefore there are four favorable outcomes by total 8, so therefore 1 by 2. Second question, at most two heads. At most means maximum two heads. Should not be more than two heads. Can be less than two heads. Means no head, one head possibility, and two heads. These are the possibilities. So you have to search for all this. No head means it is T T T. One head is either this. So T T H T H T, or else here it is H T T. Then two heads H H T. Then H T H T H H. Therefore, other than HHH, all outcomes will favor this event. Therefore, P of A equal to 7 by 8. Next, third one, all heads. All the three must be heads. So, HHH, only one outcome is favorable. So, P of A equal to 1 by total outcomes 8. D, exactly one head. That should be only one head in the outcome. So, exactly one head means this HTT is favorable, then TTH is favorable. Other than these two, no outcome is favorable for this event. See one more here. I have this THT. Sorry. This outcome is also favorable because exactly one head. Therefore, P of A equal to 3 by 8. Now, last one is exactly one tail. Exactly one tail. Favorable outcomes are HHT, one tail here, HTH, here also one tail, then THH. So, HHT, THH, HTH. These are the outcomes favorable to this event. Therefore, 3 divided by total number of outcomes equal to 8. That is 3 by 8. See the second problem. In an experiment of throwing two fair dice, find the probability of getting. So here sub questions given. Two fair dice is same as throwing a die two times. So sample space will have 36 element, 1 comma 1, 1 comma 2, so on up to 1 comma 6. Similarly 2 comma 1 to 2 comma 6, so on up to 6 comma 1 to 6 comma 6. Okay, in between. So n of s is equal to 36. So see the first event, getting a doublet. P of A. Doublet means same number on the two dice. So 1 1 is doublet, 2 2 is doublet, 3 3 is doublet, 4 4, 5 5, 6 comma 6. So there are 6 possible outcomes favorable to this event divided by total 36. So 1 by 6. Second one, sum must be equal to 7. So sum equal to 7. When you add those two numbers in the first die as well as second die, sum must be equal to 7. Therefore, we do 1 comma 6 because 1 plus 6 is 7. With the 2 comma 5, with the 3 comma 4, with the 4 means the reverse of this, 4 comma 3, 5 comma 2, 6 comma 1. So there are 6 outcomes favorable to this event by total 36, so it is 1 by 6. Next, third question, sum greater than 8. So greater than 8 means 9, 10, that those values. With the 1 comma 6 is the maximum, sum is 7. That's not possible. With the 2 comma 6, it is equal to 8. 2 plus 6 is 8. With the 2 also not possible. Then with the 3 comma 6 is 9. So which is greater than 8. So you have 3 comma greater than 8, 3 comma 5 you don't write. So 3 comma 6. With the 4 comma 5, 4 comma 6. Both will come because here 10, here 10, here 9. Then with the 5, this reverse. 5 comma 4, then 5 comma 5, 5 comma 6. Then with the 6, 6 comma 4, 6 comma 3, 6 comma 4, and 6 comma 5, 6 comma 6. So total outcomes favorable to this event 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So P of A equal to 10 by 36, which is equal to 5 by 18. Next D, 3 on first die and multiple of 2 on second die. So first die 3, multiple of 2 starts with 2. So 2, then it can be 4, then it can be 6, multiple of 2. 8 not possible because 8 won't appear on the die. So 3 on the first die, multiples of 2 on the second die. Therefore, 3 favorable outcomes. P of A equal to 3 by 36, 1 by 12. Then last one, E, prime number on first die and odd prime on the second die. Prime number on the first die. So first smallest prime is 2. You can start with 2. Odd prime on the second. Odd primes are 3, 5, 7, and so on. So out of which 3 and 5 are possible because these are the numbers appearing on a die. 3, 5. So 2 comma 3, 2 comma 5, odd prime number on the second possibility. Then 3 comma 3 with the 3, 3 comma 5 with the 5 now, 5 comma 5, odd prime 5 comma 3. So favorable outcomes are totally 6. Therefore, P of A equal to 6 by 36, which is nothing but 1 by 6. So this is how we calculate the probability. Now take up one more problem. This is problem on playing cards. Out of 52 well shuffled playing cards, 2 cards are drawn at random. You have to find the probability of all these events. So first you have to understand there are totally 52 playing cards and there are 4 types in those 52 playing cards: hearts, clubs, spades and diamonds. So each type has 13 cards. So total 13 into 4, 52 cards. So Jack, King, Queen, these are called as face cards. In each type there are 3 face cards. Therefore, totally there are 12 face cards. And there are 26 red cards and 26 black cards. These are the basic things you should know in playing cards. So before solving the problem. See the first one, n of s you have to find out. The random experiment is drawing 2 cards from a well shuffled pack of 52 playing cards. So drawing 2 cards, how many possibilities will be there? Total outcomes is 52C2. C2 means a combination. Choosing 2 cards out of 52 cards. So the possibilities can be 52C2, that you have to find out. 52 factorial by 52 minus 2 factorial into 2 factorial. So NCR formula, NCR equal to n factorial by n minus r factorial into r factorial. This is the concept of combination here. So 52 into 51 into 50 factorial, I'll split it up like this, into 2 factorial, which is 2, cancels. Then 2 2s are, then 2 6. So you will have 26 into 51. Now see the first event, one red and one black card. So 2 cards you have to draw, out of which 1 card must be red card and 1 card must be black card. So you have to remember one thing, whenever you will get and in the question, it is multiplication, fundamental principle of counting only. It is a multiplication, addition principle and multiplication principle you have. And comes means it is multiplication, or is there means it is addition. So I will explain how it goes. One red and one black card. So there are 26 red cards. I have to choose one red card. So 26C1. Then there are 26 black cards. I have to choose one black card. So 26C1. That can be done in these many ways. So one red and one black. So 26C1 into 26C1, because there is and. So I am finding the probability of this event divided by Total number of ways is 26 into 51. So 26C1 is value is 26 into 26 by 26 into 51. So 1 of 26 will cancel. So you'll get 26 by 51. Now, second question, both cards are of the same suit. Suit means type. Both the cards are of the same type. So, two cards I have to draw. The two cards should be of same type, means those two cards must be heart, or those two cards must be club, or like that. Two cards, two hearts, or two clubs, or two spades, or two diamonds. Now here fundamental principle of counting addition, because or comes. In how many ways you can choose two hearts out of 13 heart cards? So this is 13C2, or means plus 13C2 plus 13C2 plus 13C2 divided by total number of ways 26 into 51. So that is P of A equal to, this is equal to 4 times 13C2 by 26 into 51, which is equal to, so that is equal to 4 into, this is 13 into 12 divided by 2 factorial, which is 2 whole divided by 26 into 51. So 2 ones are 2 twos. So here you have 2 into 13 into 12 divided by 26 into 51. After simplifying, you will get it as 4 by 17. Now the third one, see, one jack and one other one king. So one jack card. Totally, there are four jack cards, because one jack in each type, so four jack cards. So jack 4C1 and means into other card is king. Four king cards, therefore 4C1. P of A equal to divided by 26 into 51. That is 4 into 4 by 26 into 51, which is equal to 8 by 663. This is the probability. Then last one, D, one red and other of club. So one red card and other card must be of type club. So how many red cards? 26. 26C1 into other, and therefore into other of club. Another card must be of type club. There are 13 cards in this type club. So 13C1 divided by 26 into 51. This is the probability. So that gives you, you simplify this, you will get the answer as 13 by 51. So this is how we calculate the probability using classical theory of probability. Now, odds in favor of and against the happening of an event. Suppose S is the sample space of the random experiment, which has n of s is equal to n elements, and a is any event. The favorable outcomes for a are n of a equal to m. Then odds in favor of a is given by, that is m is to n minus m. Odds against the event a is given by n minus m is to m. This is how we state odds in favor of the given event and odds against the given event A. It is easy to remember. Odds in favor of means P of A is to P of A dash, the ratio. Odds against A is P of A dash first, P of A dash is to P of A. So, this is how we define odds in favor of the event A and odds against the event A. Now, some problems related to this concept. See, if odds in favor of event A are 3 is to 4, what is the probability of happening of A? So, odds in favor of event A. So, it is given P of A is to P of A dash is equal to 3 is to 4. Therefore, P of A equal to the total outcomes favorable 3 divided by total number of outcomes is nothing but 3 plus 4, because if A occurs, A dash will not occur, A dash occurs, A will not occur. So these are mutually exclusive and exhaustive, hence the total number of elements in the sample space is obtained by adding this. So it is 7, P of A equal to 3 by 7. So what is the probability of happening of A, which is P of A equal to 3 by 7. Next, find the probability of event A if odds in favor of A are 4 is to 3. So P of A is to P of A dash equal to 4 is to 3. Then P of A dash is to P of A equal to 5 is to 8. Odds against A are this. You have to find the probability of A. So P of A equal to how much? This you have to find out. Very simple. P of A equal to here. Probability of A is 4 divided by number of outcomes favorable to this event A divided by 4 plus 3 is 7. So in the first case it is 4 by 7. Similarly, in the second case, you have to find out what is the probability of A. P of A equal to a number of outcomes favorable to the event A. Now it is 8 divided by total number of outcomes 8 plus 5, that gives you 13. So it is 8 by 13. One more problem. If P of A is 3 by 5, find the odds in favor of A. So odds in favor of A is P of A is to P of A dash, that is equal to P of A is 3 by 5. Correct? No. So number of outcomes favorable to A are 3 is to, what is P of A dash? Total outcomes 5, out of which 3 are favorable to A, hence not favorable to A are favorable to A dash. So 5 minus 3 will give you 2. Second one, odds against this event A means P of A dash is to P of A, which is equal to, just reverse this, 2 is to 3. This is how we find out odds against the event and odds in favor of the event. I hope you understood the concept. Thank you for watching.